Hello, ladies and gentlemen. This is WeatherBrains, episode number 663 for the 1st of October, 2018. And we are on the air everywhere. This is the part of the show where we share boring personal stories, humorous anecdotes, and we say outrageous things.
And fall asleep during the pre-show.
So, Bill, I can't find Aubrey. This is odd.
What do you mean? Her handle went away?
Yeah. It's just like not that. Maybe she just ditched us.
Maybe she's been banned temporarily.
I don't know. I probably need to find her email address, I guess, to do it that way.
Yeah. Address if you want me to.
I don't know what's up with that.
There's the
Let's get social.
Hello.
Let's get social.
Social.
With social media.
I can hear the drops this week.
Yeah, I have. I've been using a virtual audio patching system for Mac called Soundflower, and that has technically not been supported for like 2 years. And so I just went ahead and just reconfigured everything. I upgraded to the new operating system, which has been smooth and stable on the testing machines here. And I'm not using Soundflower anymore. I'm using a paid program from the same company that makes Audio Hijack, which is how we do the magic. But I have to do that to route the audio down the Hangout channel so you guys can hear it. And first time I've tried it here, but it seems to work. What is this program? Loopback. That's the name of it. Loopback.
Have you invited
Yeah. I'm about to do that now. A little worried about Aubrey. That is just so odd. Normally when I type, her name, it just comes right up. And that is just so stinking.
Email, but that hasn't seemed to work very well lately. So,
let me see if I can come over here to Hangouts and find her info this way. Yeah, Google's always in a state of change. It's like they're kind of, I don't know where they're going with this whole thing. Let me see.
may just be you and me.
Or it just could be the two of us here. I mean, it's like
sounds like a Grover Washington Jr. song.
Yeah. I can see a phone number for her on here, but I don't see like an email address where you can add it in here very easily. That is just so stinking weird.
Text her real quick.
Yeah, if you could see. See if she's changed any email address or deleted something. I will put Bill in the chat. This is the actual link to the Hangout. So she, in theory, goes right to that. It should come up. So
I think that everything past the E is what has been getting me in trouble when I send the email. That's because if you just pull it right out of the browser, I think there's some extra code there at the end. I'm not sure what that HL equals EN means, and that may be what has been causing issues when I tried
I, say,
to.
I don't. When I paste it in the chat room, I don't see anything like that. It's just a.
Yeah, I think if I cut it off right there, it might work better.
The science is in. Science.
This whole show tonight's got climate change all over it, so you got to
The science is in.
Science.
Let's run through now the latest hurricane statement on Hurricane Camille.
That is so cool.
That's a classic.
Norcross reading an advisory of Hurricane Camille. I got the new version of whatever for the iPhone, and I had the most beautiful disc trail Saturday morning when I was running to send you, James, and I couldn't get it to go out over my Twitter feed. So it's kind of good. It probably saved me for some chemtrail bashing over the weekend.
Goodness, I haven't.
Hi, this is Leo Laporte from This Week in Tech. You're listening to WeatherBrains.
How's Leo? I haven't listened to his shows in a long time.
I think he's still cranking them out. Time. I've gotten to where I listen to No Agenda with Adam Curry and John C. Dvorak, and their show runs 3 hours and it's twice a week, and that kind of limits the time I have to listen to anything else. Those guys just make me laugh, and sometimes we need to laugh a little bit,
a lot,
and yeah.
Everyone says Aubrey.
I don't know. We're here. We're about to hit the television side here in 8 seconds. So stand by to join TV. Good evening, good evening, good evening, good evening, and welcome to our television viewers. This is WeatherBrains, the pre-show. This is Monday night. You know what this is? It's Monday night. We're gathering together around this finely polished digital mahogany table to talk about our favorite subject, and that's weather. And we do this every Monday night. For those of you watching on television, you're in the Central Time Zone. 8:30 p.m. is when we hit the magic button here. We take over the radar. Things are calming down. We had some flooding issues in northwest Alabama, but that's all kind of calmed down, and we might not see much on the radar for the next 3 years at the rate we're going here. So, but it's October. It is that time of the year. So we're in the process of trying.
13th and 14th, we might have some good rain, James.
Yeah. It looked pattern flip maybe at mid-month. So Bill and I might be the only two people here tonight. So this could be either the greatest or the worst.
I'm betting on the worst.
Yeah, there's no doubt. But we've got
unders. Just pretty high.
So, and again, just to give you an update on some of our folks here, there comes the lovely Aubrey. Aubrey, I couldn't find you for years I've typed in your name and immediately it just comes up, and tonight nothing.
I don't know what would have happened.
It's some Google thing, I guess. That is so stinking strange.
I wondered because I was, and can you hear me okay?
Yeah, you sound great.
Yeah, because my phone usually I get the ring on my phone and I'll hop on the computer, and I thought, gosh, is my clock right? So
yeah, it's like you're not there anymore. That is so strange.
We were frantic.
I know, and then I get a urgent message from Bill. Where are you?
Are you alive? Are you okay? Have you deleted your social media accounts?
No, I'm as much as I would like to, I have not. And I don't know why my camera's blue. I don't know why I'm blue.
Are you sad?
Oh, that's
bluer than
nope,
blue.
I'm still blue.
Sing that song, James. Bluer than
Michael Johnson, I think. Let's see.
Is there a song you don't know? I want to play.
Let me see if I can. Yes, I got. Yes, the guy's name was Michael Johnson.
I want to do guess the artist with you in the car when some trip you got to go on.
I don't know if you can hear that. I got it playing over in the. This was from 1978.
ASCAP and BMI are on the phone. They want to talk to you.
Yeah. Yeah. See, this is not coming down the official channel. This is just something playing in the background that I have nothing to do with.
Yeah, it's funny in a hotel. You can have one television playing in the lobby, but if you have two televisions playing in the lobby, you're subject to the fees.
All right. Hey, Bill, tap on that mic. We get some weird funkiness. Aubrey, how would you describe that noise?
A slight annoying buzz.
Yeah.
I have to go kick some people off Fortnite.
No, I think you do have some constrained bandwidth issues there. I think that might be part of it.
Let me go get the CEO too.
Oh, now we're getting the teletype. It's like Morse code.
Yep. Yeah, Bill's always got some issue every week. So I was going to run down before we start. In fact, we don't even have a guest on here, which is fine.
Where is everyone?
It's like, so here's the deal. And I'll do it again once the audio show starts, but Brian is on medical leave. And
Is he okay?
Brian he'll be out for a while. And, it might be a couple of months, but he's out on medical leave. So we've got Brian out. We have, obviously, Kim is on maternity leave. So those two are going to be out for a bit. Kevin has been dealing with some health issues in his family with his father. And so that's his situation. Rick, I don't know. I've not heard anything from Rick today.
I think I got an email. I think he said he was out, but I was half paying attention because I thought it might have been from last week. I'm not sure. We need like a temporary panelist.
Yeah, we do. I've got a couple.
No, that's from Rick last week. That was on the 24th. Okay.
Yeah,
motion to
Bill. You still got. Bill, we got to work on that audio. It's I don't know if you can unplug or replug. Well, he just hung up on us. Wow. I mean,
you and me, James.
Yeah, we are taking this show to the top.
All the way.
In fact, I need to pull up. See, what's so sad? Bill works so hard with this calendar, and I'm very guilty about not looking at it.
I glance at it. I mean, it's a nice reference. We have Ethan Gutmann.
Ethan Gutmann, a hydrologist in the Research Applications Lab at NCAR, has a background in hydrology, geology, and computer science. And he was able to find a happy combination of these in remote sensing, atmospheric modeling, while in graduate school. Okay, so we'll see if we can get Ethan in here. We got Bill back.
How's that? Is that better? No.
There's still a little something.
Yeah, it's
what we can do. Oh, I'm excited because UVerse is coming, or whatever it's called. AT&T fiber.
Yeah, gigabit fiber. That's what I have at my house.
What's the name of the package you have, James?
Yeah, I don't know. I got the full.
Is it Internet 1000?
Give me. I don't know. Whatever you got, give it to me.
Yeah, that's what I'm getting. This week.
In the real world, I get like in the house. I have an Eero. I use Eero routers, and Eero does a daily speed check just automatically, and you can look at it on your app. Anywhere to see where. Bless you.
Thank you.
To see what your speed is, and I think one morning it did over 900. Most mornings it's 700 or 800 something. Up and down. It's not async. It's synchronous. It's pretty darn good. And I
have multiple access points in your house.
Yeah, I got 3. And Eero is mesh. It's a mesh network instead of the old fashioned stuff. It's got some extra radios to do some backhaul stuff. And so I've got 3, and it really works well.
Get someone to do it.
Yeah. I set it up about. When we moved into this house about 2.5 years ago, and
can you tell me the name of it again?
EERO, and you can buy them at places like Best Buy or order it. It's very easy to set up, and it's a true mesh network, and we're going to send them an invoice after this show for the free commercial. In fact, what you're going to, instead of paying us money, just send Bill a free, 3 router system for his house.
Yeah, that'll be good. That and a couple of months of free Internet 1000.
Yeah. And what's kind of weird, I have to run mine in a bridge mode. The routing is actually done by a router that's in a rack that just has to work that way, but it's in bridge mode, but it's still true mesh Wi-Fi. And even at the farthest end of the house, and your Wi-Fi speeds will be a lot slower. You're not going to get 800 on Wi-Fi, but I've in many situations been doing 300s and 400s on Wi-Fi at the far end of the house, which is just stunning.
Well, I've got a 5G access point right above me, and still we have these issues.
Yeah, can you unplug that? Yeah, it might be that audio interface. Can you unplug that thing and plug it back in? It's not bandwidth. It's something to do with hardware. And if nothing else, he can go on these things, these ear pods. We can use his mic. Uh-oh. You know what I just did? When you double tap on this thing, you invoke Siri. I forgot about that. I double tapped on one. And can I help you?
No.
Is that better?
Like that. Talk for a minute.
How about now? Testing 1, 2, 3. Testing.
No. It's kind of distorted as you talk and noisy. Can you go just to the?
Yeah, we're on the AirPods now. How about that?
Yeah, let's do that. The audio is not as good, obviously, but it's not but it's fine. It is much better.
Okay, good. Well, maybe the fast track has exceeded its useful life.
Hello.
Hello, Ethan.
How are you?
Pronunciation check, Ethan. Gutmann or Gutmann?
Gutmann.
Scott was wrong.
How much did you
Aubrey
win?
was wrong and I was wrong.
I was wrong.
Yeah, I was wrong
y'all
too.
y'all talked about this while I was running around the house?
We just threw the
chasing
name
people
out
off
there.
Fortnite?
We were curious.
Okay.
We were checking our schedule.
Thank you. That really helped.
All right, so let's see here. I think we're all gathered together. Let's get this thing started here. We're only 10 minutes late. That's not too bad. And again,
We're not to the
I
Amtrak level tonight.
Yeah, I'm using
Delta Airlines level.
A new routing system called Loopback.
Loopback.
I just threw my microphone on the floor.
Yeah, about to say something.
Whoops.
So we'll see if we can make this puppy fly. So let me get the recorders going here. This is recorder number 1, and this is track number 2. And here we go in 5, 4, 3, 2, 1. Hey, this is WeatherBrains, episode number 663. It's the weekly show that's all about weather. This is for Monday, the 1st of October. I love this month. 2018. Thank you for taking the time to watch or listen. And for those that have been listening or watching for a while, you know that we have a number of our regulars that are going to be out of pocket for a little bit. First off, Dr. Kim Cloko-McLean is on maternity leave. Mom and baby are doing just fine. She'll be back a little later in the year. Brian Peters is on medical leave. He'll be out for a while. Kevin Selly has been dealing with some medical issues in his family. He will be out for a while. Let's see who else has a good excuse here. Rick Smith, we don't know where Rick is. Apparently it's 50-cent beer night at Hooters in Norman, Oklahoma. So
the third person to be spotted at Hooters off the show.
Yes, exactly. And Nate, Nate traveled, and I'll give Nate a break. He was with us during Hurricane Florence, and we had a great show with Nate. He was on for that one. But for those that don't know, Nate is kind of the tallest hog in the trough in terms of weather with the NBC-owned stations. So he is now a world traveler, and he might be flying somewhere tonight. Who else is missing here? I think everybody else is here. Aubrey, I'm glad you're here. You're in Edit Bay number, which number?
I'm in 2 tonight.
2.
Two.
What does it mean?
I'm not sure. It's 2 out of 4.
Okay.
But I'm fresh off vacation, so I'm back.
Welcome back. It's good to have you back. So where is it nosy to ask where you have been or what you did?
I think I put about 2,400 miles on my car in 10 days. We went up to Connecticut, drove all over Connecticut and Vermont, drove all over Vermont. And then I tagged on I had it arranged to where I picked up my aunt in Shaftesbury, Vermont. And then we did a family thing in Erie, Pennsylvania. My uncle owns a theater in Pennsylvania. So she was able to ride with us and then fly back home. So then we did a thing in Erie for the weekend and then came back home and got in last night.
So, are you chasing some fall foliage?
No, it was a little early on the foliage. I don't think I could have planned it around the foliage this year with my schedule and stuff. It was just a little early, but it was starting. So I would say it was probably about 30% in Vermont when I got there, but some cool stuff and just got to go home. I mean, I'm from Connecticut, so got to go back to the shore and eat some amazing seafood and have a lobster roll, which I haven't had in many, many years. And that's the Connecticut. If you're not familiar, there are two kinds of lobster rolls. There's the cold lobster roll, which is kind of like a lobster salad, which is not so much. The Connecticut lobster roll is the hot lobster roll. It's the buttery roll with the fresh lobster. Good stuff.
I bet she didn't bring us any, James.
I know.
No. But look what I got. I have a Mount Washington hat. I mean, I didn't get a chance to go, but you were up in that neck of the woods. But one of our news anchors here actually went up to the summit and went up there, and she was kind enough to bring back a brand new Mount Washington hats. But you were how close were you? You were.
I was probably about within 3 hours. I was close, but not that close. And I had thought about it, but it just wasn't going to work on this trip. So the next trip, I'll make it worth it. And have we ever had anyone from the observatory on before? I'm assuming so.
We have, but we certainly need to have another one again soon.
Sounds like it.
Yeah.
Maybe.
All right, Bill. Let's bring our guest in. Let's bring our guest in before he hangs up and runs.
Yeah, surely. Hopefully, he won't do that. It's going to be a great show tonight. Got great talking points. Scott Martin worked really hard getting Ethan together for us, and I'm really excited about it. But joining us for this episode of WeatherBrains is Ethan Gutmann, a hydrologist in the Research Applications Lab at NCAR. He has a background in hydrology, geology, and computer science. He was able to find a happy combination of these in remote sensing, atmospheric modeling, and he joins us tonight. From where are you? In Boulder?
I am. Well, I live outside of Boulder. Nobody can afford to live in Boulder.
It's pretty much over, isn't it?
So I'm actually at my house in Louisville, Colorado, just outside.
Now, I saw Estes Park pop up as one of those really cool places to live recently, and we were recently there on vacation. Is that like a bedroom community to Boulder?
No, so Estes Park is about almost an hour's drive away.
Is it? Okay.
It's right outside Rocky Mountain National Park. So it's a beautiful place to go visit, although it gets mobbed with tourists in the summer. Warning.
Yeah, I think you're right. We were there on the high tide of the tourist season when we were there, but it was certainly an incredible experience.
It is also, I believe, one of the, if not the most popular place to get married in the U.S.
Really?
Yeah.
Well, there you go. So, well, we're so glad you're with us. Your paper caught our attention, and I've had a great time reading it. Over the past few weeks, Scott had a great time reading it too, and we've got some great questions for you. So, of course, tropical cyclones are always in the news. Huge impact events, and with a changing climate, with a warming climate, there's lots of fear that these things are going to get worse and bigger and more frequent and all of these things. So you've done some research in regards to that. And so we'd like to kind of walk through your paper tonight a little bit and have you explain some of it to us and give us some background and things like that. So if you're up for that.
You want to start off with questions? You want me to just try to give you?
No, you think sea surface temperatures get warmer, intensity is going to go up, frequency's going to increase. It just seems to stand to that. So talk for a moment about changes that have happened in sea surface temperature and what the research is on that right now. What's the data say?
Well, so let me step back one piece there, because you said intensity is going to increase, frequency is going to increase. And I think there's actually a lot of debate, particularly over frequency, that the number of tropical cyclones in the future may not be any greater. There's a lot more consensus that they'll be more intense. And as you say, a lot of this is driven by sea surface temperatures. And so this is one of those pieces we have a really high confidence in the climate change signal, that we can see sea surface temperatures increasing. All of the first order physics points to increasing sea surface temperatures in the future. So it's one of those sort of very clear signals that we can be confident in. And then we can get to this a little bit later, but the key piece of this paper is really doing just that, trying to take some of the core pieces of the climate change signal that we're confident in and try to understand what those mean, or will mean for tropical cyclones.
So why do you think, Ethan, that genesis and formation of tropical cyclones and numbers are not going up correspondingly? What's the general consensus on why?
So it's hard. There are so many factors that go into forming a tropical cyclone in the first place, including just chaotic variability. They're just large convective systems, and convection is a highly chaotic process. And so there's some debate over sort of how much energy these systems are transferring from the equator to the pole. And if you just make them more intense, that is therefore transferring more energy. So you don't need more of them. And if you have more of them, then you're transferring maybe too much energy away from the equators. And so it doesn't quite balance out with the incoming energy, right? There's more energy at the equator because there's more sunlight there. There's less energy at the poles because there's less sunlight there. That sets up this strong temperature gradient. And so tropical cyclones are one mechanism of sort of transferring energy through the system. And then it's factors like the formation of tropical cyclones, particularly in the Atlantic, often starts with easterly waves coming off of Africa and sort of large scale flow patterns that those patterns may or may not increase in the future. We don't, that's one of those pieces we really don't have any confidence in. And so trying to predict the frequency of occurrence in the future is a much harder problem in a lot of ways.
So how does the mean circulation change in a warming climate? Do we have any theories and hypotheses about that?
Yeah, and certainly we understand that there's likely to be more of an increase in temperature at the poles than at the equator. So that changes the just temperature gradient from the equator to the poles. And it's that temperature gradient that drives a lot of the winds coming, just large scale winds around the Earth. And so when you decrease that temperature gradient, there's an expectation that this will decrease essentially things like the speed of the jet stream, right? That's one way of thinking about it. And that may correspond to a jet stream that's a little bit more wobbly, that's sort of going up and down, getting bigger wave patterns, which corresponds with having both more intense heat waves, but also more intense cold snaps. You get that the polar vortex extended down, as we've had it for a few years in recent history. So it's
already breaking news. There's going to be more severe weather and more winter storms in your neck of the woods. So yeah, so what you were referring to, and moving energy from the tropics to the poles, and that's what you call power dissipation, right? In your paper, is that the same thing? Is that what you mean by that?
So what we're talking about in the paper is really focused on the individual storms and what goes on with them. And so when we're talking about power dissipation, we're talking about how much energy the tropical cyclones can dissipate locally, and that comes from a few processes, just in terms of this convective motion that is then heating up higher elevations, which tends to drive more convection, but that also is sort of removing some energy from lower elevations. And then also the winds that you get that are so intense from tropical cyclones going over the water stirs up really large waves, which in turn causes a lot of friction and slows down the hurricane, slows down the winds. And so it's that removal of energy from the tropical cyclone into waves in the ocean that's another really hard piece to understand and model correctly. And I by no means think that we've finish that process. But that removes energy from these tropical cyclones, which limits their growth. And so understanding some of those trade-offs is one of the places that's where research has to go next, essentially.
So how you mentioned the gradient decreasing? Does that relax the wind shear also, or does it change it in local ways, in different ways?
Oh boy, see, I'm going to get in trouble somewhere in here because I don't have that strong meteorology background. As you introduced me, I'm a hydrologist, so I get to fall back on that occasionally. No, it's so. What is driving the changes in wind shear? Yeah, that's one of the questions I'm going to have to beg off on a little bit. That I don't have a good sense of what's driving global scale patterns in wind shear. We do see an increase in stability of the atmosphere in the future coming out of global climate models. And that's driven by a combination of factors, but one of them is really just the convective parameterizations within global climate models, which is another piece we don't have a lot of confidence in. And so that increase in stability that's predicted is likely to sort of dampen the potential for tropical cyclones, but we really don't have a good handle of how confident we are in that change in stability in particular. And so yeah.
And there was an excellent paper at NWA this year about, all the years of the sounding analysis that are out there at the SPC, and how that's, how those changes are showing up over the past, nearly 60 years. And some of those same factors were at work, a northward retreat of the jet stream, decreasing wind shear, increasing instability and, severe weather regions. All these things were kind of at play. And the data really showed, these changes happening. It's fascinating talk. I don't think Aubrey was still there when that talk happened. I think it may have been on Wednesday. But Aubrey, maybe you got to see it. And so this is really fascinating data. And so some of that's at work here too, huh?
Yeah, and there's a great paper looking at not so much soundings, but just looking at tracks of cyclones from the past 50 some odd years. So just observed tracks and seeing that the motion of tropical cyclones globally seems to be decreasing. And that's not the speed of the winds in them, that's how fast the tropical cyclones are moving across the ground.
And you showed that in your research, didn't you? There was a decrease of a couple of miles per hour.
Yeah, it's kind of fascinating. Because
talk about your methodology for a minute. You first tell me what the ERA interim is. What is that boundary?
Yeah. So when you're breaking up a little bit here, hopefully I'm still coming through.
Yeah, now you're better.
All right. So ERA interim is the ECMWF, so the European Center for Medium Range Weather Forecasting's main reanalysis product. That is, so a reanalysis is a global atmospheric model run for sort of the historical time period where it's trying to incorporate every observation we have, so it forms our best representation of the observed atmosphere over the last 30, 40 years. So we use the ERA interim reanalysis product as the boundary conditions for our atmospheric model. So in our study, we ran a really high resolution atmospheric model to try to simulate a lot of the convective processes that are important for hurricanes explicitly. And to run that, you have to give it something on the edges of the domain. And so we use the ERA interim reanalysis data that gives us sort of the observed atmosphere, so that when the model's running, it's essentially just simulating historical weather, which is what it did.
So you're using the WRF, right, as you're modeling?
Yeah.
Based on those conditions, and were the actual hurricanes already there, or just the conditions that set them up?
So a little of both. So for the most part, it's just the conditions that set them up. But we were running WRF, the Weather Research and Forecasting Model, where we ran it continuously for 13 years. So there was no initialization of hurricanes within the model domain. Okay. But on the boundaries, right? So because it's the observed weather, essentially, when the tropical cyclone passes across the boundary and into the model, there's a point in time when the boundary conditions are prescribing the winds for that cyclone.
And so that was when you picked it up at that point, right?
Exactly.
Did it pick up all of the cyclones, or were some excluded?
No, that was one of the interesting things. It picked up almost all of them. It was impressive how good a job it did with that. We weren't really expecting that when we first set up these simulations. There's one in particular that I think is a great example of why this is difficult, which is simulating Hurricane Charlie. Hurricane Charlie was this fairly narrow hurricane that moved really quickly through the domain. And when it happened to cross the boundary where we're prescribing it, it was really weak at that point in time, and it moved across the boundary really quickly. So there just wasn't a lot of time where the era interim analysis was forcing a hurricane to form. And as a result, nothing actually happened in the model. So we didn't simulate Hurricane Charlie at all.
So was that boundary in the southeastern side of the domain, somewhere around the western side of Hispaniola, the Haiti,
Exactly.
that area, southeastern Bahamas?
Just south of Cuba, I think. Yeah.
So any special effects that domain may have caused in the modeling in terms of closeness or proximity to land or anything like that? It's a political call. Hold on a second. Let me hang up on.
I don't know. If they're going to be in charge of your funding, you better take it.
Whatever. Yeah. That's what we should do, Aubrey. Well, Aubrey's not here, but we should run political ads, James Spann, on the show. What do you say?
Oh, brother, please.
Maybe we make some money at least every 4 years, James.
Yeah.
We've been doing this, Ethan, for 15 years, and we haven't made a dime yet. but we sure have a lot of fun.
Yeah. Well, maybe you're doing it right. Yeah. So the nice thing about having the boundaries where we did is that it does allow the hurricanes to be pretty strong when they're coming into the domain. So they are forced well by the boundaries. But it also means that we're not able to simulate the formation of hurricanes. Yeah, we did. Some hurricanes form within the domain, but for the most part, it means that our study can't tell you about the frequency of hurricanes in the future because we're forcing them to occur, basically.
Did some of those hurricanes that formed actually correspond to real storms?
Yeah, they were much less likely to actually follow the track of the observed storm. So we tended to leave those out of the analysis because when we're looking at change signals, we don't want to be comparing two storms that went in different directions in the future because then it's not really the same storm. So for the most part, we only analyze the storms that really followed what happened in reality and did the same thing in the future, roughly. But there were a few storms that would just spin up in the middle of the Gulf of Mexico, semi-randomly, exactly the same way the real storm did. It's kind of cool.
So was there any track changes that you noticed that were consistent, that were statistically significant in terms of how the model predicted tracks to turn out from the way they really were?
In terms of the actual locations of the track, like which direction they went, not so much. Some would go a little bit further north. Some would, it's just somewhat random.
But pretty close.
Yeah, but in terms of the speed that they moved, there was a statistically significant reduction in the translation speed. So how fast the storm itself is moving from point A to point B. So the future climate, they were moving a little bit slower, basically. Faster winds, but slower motion, kind of.
So in your data across the study, you saw a decrease of 0.6 meters per second, right? Or which is around 2 miles an hour, I think.
Yeah, exactly.
So that makes a big difference in a storm like Harvey or anybody like that. Did you get to study Harvey? Was that before the paper or the data completed before that?
Yeah, no, our simulations ended in 2013, so we didn't have Harvey. And it was, I think, part of the reason this paper has been picked up a fair amount in the press is that one of our really compelling take-home messages is that the amount of precipitation coming out of the future is going to increase. And we've had a number of storms recently, both Harvey and Florence, where the precipitation was really the factor driving the most damage. So we didn't simulate Harvey, but yeah.
So you saw an increase from 83 millimeters per hour to 103 millimeters per hour.
Yeah, that's
across the entire data. That's pretty significant.
Yeah, so it's something like a 20% increase, just all storms all the time. Is and that's the maximum precipitation rates in sort of a fairly large area, not the average in any particular region. But it's those heavy, intense precipitation events that really cause a lot of the flooding that are a problem. And it goes along with all of our sort of expectation of changes in climate, where we should have warmer temperatures. Typically, the relative humidity isn't changing that much in the future. So if you have warmer temperatures, the same relative humidity, you're going to have more moisture in the atmosphere. Once you run that through a tropical cyclone, it just gets squeezed out of the atmosphere, and so you get 20% more precipitation.
So how much of the increase could you tell was related to the forward speed difference, and how much of it was water vapor in the air, et cetera, et cetera?
So pretty much all water vapor in the air. So we weren't looking at changes in accumulated precipitation due to the change in translation speed. We were really looking at changes in just maximum intensity of precipitation, which is independent of the translation speed. But if you add the two together, of course, you're going to get even more water on the ground.
Now, overall, you saw a statistically significant increase in wind speed across the data set. Many storms were stronger. Some were statistically significantly stronger.
Yeah.
Some were actually weaker.
Yeah.
From what you saw, but some of them were interesting, like Isabel, which Aubrey knows well. That was before Aubrey was a meteorologist, I guess, but she knows all about it.
I've done a lot of research on it.
Yeah, because it came right into her backyard.
Mm-hmm.
And you saw a significant increase in the radius of maximum winds, Ethan, on that storm.
Yeah, and just like the wind speeds, the changes in the radius of maximum winds was sort of variable from one storm to the next. So it's really hard to say why any particular storm did what it did. I actually went through a whole bunch of analysis after some of the reviews came back from this paper, trying to understand, like, why did some storms increase and some storms decrease? And was there any factor that we could point to? And there just really wasn't anything consistent. It was kind of too bad. It's not like the larger storms got larger or the smaller storms got larger. There just was no consistent trend across this.
Yeah, it's fun to pick out the individual storms, which is absolutely the wrong thing to do, but always kind of fun to do. Wilma, which of course was a monster, across a large area, you saw a significant decrease in the central pressure, which would have been phenomenal because it was already incredible as it was.
Yeah.
Rainfall rate significantly increased, and actually saw a fairly significant increase in wind speed on that one. That was interesting. Ike was interesting because it had higher wind speeds. And it kind of storm, if I remember correctly, that barreling into the Texas coast is this big monster storm.
Was it the Texas coast, or was that more I'm thinking of Ivan that hit the Florida Panhandle.
Yeah, Ivan was our storm. Too bad Brian Peters isn't here tonight because it came into the Alabama Gulf Coast and was an amazing storm for us in 2004. Yeah. And James, you ought to see the rainfall rate increase on that bad boy, 91 millimeters per hour to 121 millimeters per hour. We set our daily rainfall record at Birmingham on that day. James, if I'm not wrong, didn't we?
I want to say it was 10 inches?
Yeah, we got 10 inches of rain.
Something like that.
How would you like to have about 15 more hours of 30% more rainfall, James? How about that?
Remember a storm by the name of Hurricane Danny, Bill, back in the late 90s?
Absolutely, yeah.
That one, I want to say,
on the Alabama Gulf Coast. Yeah,
3 feet of rain at Dauphin Island, and I do believe that is the Alabama record for tropical or rain directly in association with a tropical cyclone. But Dauphin Island was just inundated.
Yeah, the eastern shore of Mobile Bay, all that area in there too. Fairhope had phenomenal flooding off of that storm, and it's one of those where the steering currents just collapsed and it just sat there. So yeah, that was an amazing thing. You mentioned a wrinkle of cold wake, Ethan. What did you mean by that in the paper?
Yeah, so that's
how that affected things.
That's one of the big problems of trying to simulate hurricanes, is that the hurricane is so intense that it's just mixing up the top layer of the ocean. And so very often a hurricane mixes colder water from deeper down in the ocean up to the surface. And that sort of forms this feedback that'll decrease the intensity of the hurricane. Now it can't get as much energy out of the ocean because you've cooled down the surface. So the way we ran these simulations, it had the naturally occurring cold wake built in because we used the ocean temperatures that had been observed at the time. But it wasn't coupled correctly to an ocean model where it was able to churn up the ocean by itself. So future simulations weren't able to change the cold wake it was simulating. So that's definitely one of the weaknesses in this paper, and it's something I'd love to see done better in the future, basically. Yeah.
That's the cool thing about research. It's building on top of other research. That's the amazing part of it.
Yep. No, there's always more to do.
Now, you mentioned that, you know, the methodology was to use a pseudo global warming method, which is a specific technique.
Yeah.
Talk about that in layman's terms for a moment. What does that mean?
So that's that piece I was referring to earlier that is trying to just tease apart the pieces that we have the most confidence in the climate change signal. So a lot of times when people are trying to look at future climate projections, they might use a global climate model directly, or they might use that climate model and use the boundary conditions, those boundaries that we're using from ERA Interim. They might use those directly from the global climate model. But there's a lot of things global climate models still have problems with, and simulating things like tropical cyclones is one of those. So what we did instead is average across a whole bunch of climate models and a whole bunch of years of simulation. We just got the average change in temperature, humidity, wind speed on all of the boundaries. So that's this sort of pseudo global warming effect, this average change, and applied that to the historical weather patterns. So we had our boundary conditions from the reanalysis product. And if the average from all these climate models said it should be slightly warmer, we just changed the temperature by a couple of degrees or whatever we computed from the climate models. So it's sort of not quite a full global warming future climate change scenario because we know there are things that are getting left out. It's this pseudo global warming that just gets you the warming pieces that we're confident in and tries to understand the feedbacks from that.
So you mentioned a couple of parameters there. Were there some others that you used in your parameterization, or what? How did that go?
Yeah, I mean, we changed more or less every variable we felt like we could reasonably. So temperature, humidity, the sea surface temperatures themselves, the background U and V wind speeds, the geopotential height, so just essentially the pressure in the air. I think those are the main ones. And then within the model domain, we're changing other parameters to account for the future climate. So the radiation budget at the top of the atmosphere changes because we recognize that we have to be simulating greenhouse gases within our model as well.
So how much did the sea surface temperatures change in your parameterization?
You know, I forget the numbers off the top of my head. It was, again, this sort of mean value from all of the climate models. And so you're talking about a few degrees Kelvin at least, Celsius, right? So probably on the order of 3 or 4 Celsius, which is 8+ Fahrenheit. Right. Very cool.
Yeah, so the stuff is just really fascinating. We talked about a lot of it, but the mean radius, the maximum wind changes. You've got fascinating images of the tracks inside the paper, which, by the way, is in the Journal of Climate. And thank you for sending that paper over. You saved me $35 for my AMS subscription today. That was.
Don't tell the AMS I did that.
James, bleep that part out, please.
Yeah, no way.
I'm going to send my $35 in anyway. Just because it's been worth it, every penny of it, to have you on the show tonight, for sure. For sure. But you haven't had a chance to run against Harvey or Florence, but I can't even imagine what the results might show if we had an even slower Harvey with a higher rainfall rate. That's really scary.
Yeah. No, it's that higher rainfall rate that's, again, it's one of the pieces we're most confident in. There's going to be more rain coming out of these things in the future. And having seen the last few storms that have done the damage they've done just from flooding, it's going to be interesting to see what that means in the future. And maybe we'll get a little bit smarter about how we're just engineering these areas to begin with so that we have better floodways and we can get the water out of cities like Houston a little faster. So that's often one of the big problems, is just the infrastructure built up.
Well, I think the other problem is, when you're talking much more rainfall, slower moving storms, you're talking inland areas, not just coastal areas.
Yeah.
So, and that can hit anywhere. So what do you do about that?
Yeah. Well, and a lot of things that aren't even tropical cyclones, right? So we saw this in tropical cyclones, but you see this in these simulations and a lot of simulations just across the board everywhere. There's going to be more intense precipitation. So I was down in Louisiana, 2014, 15, when all the flooding outside Lafayette happened. And there, it wasn't a tropical cyclone. It was just a hell of a lot of rain. And sure enough, there's going to be more of that.
Now you mentioned that some of the research shows that a mean climate change, contains a summer high pressure anomaly over the U.S. Northeast. And I'm not real smart, but I know that's Joe Bastardi's ridge over troubled water scenario. Probably. Does that mean more East Coast storms? Or are you prepared to even go that far?
No, because the way we're simulating this, it really isn't able. Again, it's not able to change the frequency of storms in that way. So it may change how fast how those systems evolve, but not the frequency of those storms, really.
You refer to a headwind. Either your research or someone else's research might be a headwind for those storms. Does that mean when they're turning to the northeast?
Yeah, exactly. And so that was really what was slowing down a lot of these storms. That the dominant track is this shift. So a lot of hurricanes move along primarily from the east to the west in southern latitudes, and as they curve to the north, they get pushed off to the east again. And so it's that track moving back to the east that gets a little bit of a headwind and just slows down all the storms.
It's fun to understand the factors behind why why the results come, and that that's where the rubber meets the road a little bit. There, you kind of see why some of these results might be happening.
Yeah, and we certainly try to. If we just ran a model and got an answer, that wouldn't be very inspiring and wouldn't give us really that much confidence. And so when we can pin down why different changes are occurring, that gives us a lot more confidence that it's meaningful.
So what years did you study, Ethan?
So we ran the simulations from, I think it was maybe October 1st, 2000 to the end of 2013. And that October 1st date really has nothing to do with hurricanes, right? Because we ran these simulations to study just the water cycle in general. And you may not be as familiar with this in the East, but in the West, we have this concept of the water year that's pretty important, where all of our water resources come from snowpack in the mountains, and that snowpack doesn't start building up until October 1st. So that's when we think of it as starting to store the water for the next year. And so it's really important to have simulations that start around October 1st.
We are always pulling for you every year. We're watching those snow totals in the Sierras and the Rockies and hoping for the best, because it sure has a big bearing on what happens in the summer.
Yeah.
Now, Scott wanted me to ask you one question. I'm sure it's probably from homework from school. He wants to know what the Clausius Clapeyron, and I may be totally botching what that equation is and what it means. And if you could speak slowly so he could record this later for his notes.
Simple words. Yeah. Clausius Clapeyron is just describing the relationship between how much moisture the air can hold and the temperature of the air, basically.
Well, I have to teach a bunch of sixth graders on Friday, and I didn't realize that was going to be part of it. So now I'm going to make them learn those two big words, because that's one of the key concepts. We're launching a weather balloon. We've done this every year for a few years. And so we trained 600 sixth graders in 2 days to be launch weather officers. And it has been a game-changing experience because it is real-life forecasting.
Oh, I bet.
Of course, one of those things when we teach some meteorological basics, one of those is that the warmer the air is, the more water it can hold. So there we go, Aubrey. We learned some big words tonight.
We like learning big words.
Yes, we do.
Hey, let me ask you guys a little news here. I just noticed a tweet from the National Weather Service Aviation Weather Center. We are sad to report that we have lost one of our forecasters, Amy Harless. Amy was known for her tremendous love of meteorology, her eagerness to always help her friends in our office in any way she could. She was loved by her AWC family and will be missed greatly. Do you know her? Anybody know her by any chance on the show here? I don't.
No, that's terrible.
She apparently had worked at SPC at one point, and I would imagine Rick Smith might know her, but you always hate to hear that tragic loss of life or however it happened. I don't know her, but it certainly seems like she was well-liked and well-loved, so we'll see if we can find out more about her life and career and talk with Rick about that next week, but that was kind of sad. Hey, Ethan, talk about climbing mountains, man. What are you doing? I mean, you travel the world, you climb mountains. Let's talk.
So now we get to the good part of the interview.
Yeah, come on, man. Let's blow this other stuff off and let's get to the good stuff here.
So the whole reason I'm in Boulder is I love climbing. I love the mountains, right? I mean, don't get me wrong. I dig the ocean too, but getting up in the mountains is what really gets my heart going. And so I've been really lucky to get to climb mountains just around the world, actually. I came out to Boulder for graduate school and met some of just the best friends a guy could ever hope to meet, and have gone climbing in Peru and Nepal and climbing on the beach in Thailand. It's not quite mountains, but it's pretty sweet. The Mai Tais are better too.
So yeah, what's your favorite
drink of WeatherBrains
so far? Yeah, there you go. That's a show title. So what's your favorite mountain climb so far?
It depends on how you rank them, right? And one of my favorites definitely around here is Long's Peak, and there's the standard route up Long's Peak that a lot of people do that I can't actually recommend. It's a really long, painful climb. But if you go for some of the more technical routes for the climbers out there, there's just this sheer granite wall of 1,000, 2,000 feet of just beautiful, clean climbing, and starting at 12,000 feet. I think the bottom of this cliff is around 12,000 feet, and the top of it is almost 14,000 feet. So you're really high up. But probably one of the best mountains in the sort of worldwide, Ama de Blanc. If you ever look that up, Ama de Blanc is often called one of the most beautiful mountains in the world. And I actually guarantee probably all of you have seen pictures of it. It's in magazines and what have you, and advertisements, because it's really pretty. Definitely recommend just do a Google image search for Ama de Blanc, AMA space de Blanc, DABLAM. It means something like the mother's necklace, because it's.
In what country is that, Ethan?
It's in Nepal. It's in the Himalayas, just down the valley from Everest. Yeah.
So how many 14ers have you done in Colorado?
I don't even know. I haven't actually really been trying to tick them off. I tend to go for more of what's the interesting, hard, scrambly climb. I've probably done 10 or 15 14ers just for fun.
So this shortcut up Long's Peak, I guess.
Yeah. Shortcut. It only takes
using crampons and just climbing up the side of a cliff. Is that how you do that?
Yeah, I say in the winter you'd have to have crampons. I've gone in there with an ice axe and crampons in the winter, but I don't recommend that. It's really freaking cold. But in the summer you're just wearing rock shoes. So it's these tiny little rubber booties basically that just grab onto your foot as tight as they can, so that you can stand on just like knife edge, little dime edges of rock, and climb up the side of the rock. It's a beautiful thing. You've got a rope on.
What holds you there in case something goes wrong, in case the booty gives up? What happens then?
Tied into a rope the whole time, right? Okay. So you tie into a rope, and as you go up, you clip that rope into pitons, or you stick little metal wedges into the rock and then clip the rope to those, so that you protect yourself in case you fall. But yeah, there's a chance that you'll fall 10, 20, 30 feet if you do fall. So don't fall.
That can't be good. James, that sounds crazy to me, James Fan. What do you think? You going to be doing that anytime soon?
No. So the next question is, how do you train for this? Because Because you just can't, you got to be in good shape to do this, right?
Yeah, and I mean, some of it's got to be in good shape. Some of it is really, it's the technical side. You've got to know how to climb. And I started climbing at a camp in Maine, actually, when I was 13 years old, I think. At Camp Winona outside Bridgeton, Maine. Beautiful little place. But then I also do a ton of bike riding and hiking. I can't really run. I have too much problems with my knees. Man.
Well,
So
James,
then
I'm gonna
how-
ask one more weather question before you wrap us
Okay.
up here, because there was one storm missing in that data set, and you know where I'm going to go with this, Ethan. But what about Hurricane Katrina?
Yeah. So we did simulate Hurricane Katrina in these simulations, but it is kind of this really weird for this particular model domain, because we had that southern boundary right around Cuba, and Katrina was north of that, but it's kind of interacting with the boundary constantly. And so as a result, the winds in the reanalysis product, this era interim, just weren't strong enough to help the storm spin up into the right shape and the right position. So the simulation of Hurricane Katrina just wasn't as strong as it should have been. It didn't put it in quite the right place. So we didn't actually include it in a lot of the analysis. I know, and that's one of the first ones people ask about, because I guarantee you it had more rain. That's it.
Hey, Ethan, can you stick around for a few more minutes, or do you need to go now? Have you got a few more minutes?
No, I'm good. The kids are in bed.
Oh, good. All right. So the deal is we're going to take a break here, and I see Aubrey is here. Aubrey, can you do email like in 3 minutes? Is that cool?
Yeah, that's fine.
Okay. So what we're going to do here, we're going to take a break for Tony Rice and the astronomy report. We're going to come back with the email segment. We've not done email for a while, so we're going to go back and dig through all the email. Aubrey's going to have that. We're going to do weather roundup. We'll talk about weather around the nation on this October 1st. We'll do Pics of the week and much more. So don't go away as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
Hollywood has a mixed relationship with science. There's some, like Contact and The Martian, that are filled with great science. Then there's others, like Twister and Jurassic Park, that get a lot wrong, but at least brought some newfound interest to their respective sciences. The remake of A Star is Born is neither. While I don't expect either Streisand or Lady Gaga to be experts in stellar evolution, Caltech and UCLA are right down the road, and that's where they make astrophysicists. Ask any of them and they'll tell you. Stars are born from molecular clouds of extremely cold gas and dust, around 10 Kelvin. Turbulence within that cloud, along with all that cold, causes atoms to clump together and create carbon monoxide and molecular hydrogen. As this density increases, the cloud begins to collapse into itself under its own gravity. Things begin to heat up at the center. This can occur in multiple blobs too, which is why so many of the stars in the Milky Way are paired or in multiple groups. This protostar continues to gather dust and material, but not all of that becomes part of the star. The remainder can become planets, asteroids, or comets in this newly formed solar system. The 2018 A Star is Born remake runs 2 hours and 15 minutes. But in reality, it takes about 50 billion years for a star to reach adulthood, where it begins producing helium through nuclear fusion deep in its interior. It's that outflow of energy that keeps it under its own mass. The movie opens this weekend, but you can see where stars are really born in the Orion Nebula, below the 3 stars in Orion's belt, when the constellation rises about 1:30 a.m. local this week. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
All right, it's that time of the show. We dig into the good old email inbox to see what's in there.
Letters. We get letters. We get stacks and stacks of letters.
All right, let's open the inbox. So this first one comes to us from John Wilkinson. I read an alert from the Cayuga Sound Festival in central New York due to an approaching line of thunderstorms, which had a history of severe warning. So they ended the concert early Friday night and had available shuttles to evacuate people if necessary, which is awesome. And he said about hearing how some bad things happen in situations like this, it was nice to see some people doing it right. So thanks, John. Of course, job well done with that festival. Dusty sent this one in, listening to the Florence follow-up for this week, and Dusty agrees that the current category system isn't reflective of storm damage. Let's see. So the question is, as far as the categories go, maybe a component of forward speed could be added. They went for a long time without a decent hurricane after 2005. And now a lot of people maybe had become a little bit complacent in the Carolinas. So a great add to the show. So thank you, Dusty, for sending that one in. This one comes from Massey Bartoloni, a longtime listener of the show, but wanted to send us the first email. And let's see, there was a part of this. Okay, over the next few years, do you think that the Weather Enterprise needs to do more work advancing the physical science and modeling to get the details of these kind of large events like Florence nailed down to the specific region for decision making or longer lead times? Or do we need to get better at messaging and trying to reach the most vulnerable populations that are impacted by these events? Which one or both is in more demand?
Yes and yes. Ethan, what do you say?
I agree. I think both is. Ethan?
Yeah, no, as a physical scientist who loves science, I think we need to do more outreach and communication, because I think that's where the biggest wins are going to be had right now.
I think there's always an opportunity for better communication, in my opinion. Let's see. And Massey also got to meet Nate Johnson last year at AMS, which was awesome. And also wants to know if we've had a recent guest on the show to talk about the latest advances in mesoscale modeling. If not, my guest suggestion would be someone from the ESRL HER development team, Stan Benjamin, Curtis Alexander, or others. The HER model has been quite popular for some of the short-term mesoscale forecasting challenges.
Dr. Span, can I have the breaking news jingle?
Uh-oh. All right. So here we go.
We interrupt this program for a CBS Radio Net Alert Bulletin.
Curtis Alexander from the aforementioned HRR development team will be joining us on Monday, December 3rd, Aubrey.
Sounds exciting.
Yes, it does.
Shall receive. How good is Bill?
Thank you for the breaking news. Ooh.
That's what a good guest booking officer does right there. Wow.
All right. This one comes from Jay Farlow. I recommend that you book Juanita Rilling as a guest to talk about problems caused by people sending stuff and self-deploying as volunteers to disaster areas like those from Hurricane Florence. Florence. Gosh.
George Foreman's now a hurricane.
Oh my!
It's Monday.
I'm still recovering apparently. Scott Simon featured her in this story on CBS This Morning last year, and also Jay forwarded contact information, and that would be very interesting to talk about that and maybe get the word out a little bit more that people should not self-deploy.
Yeah, there's a lot wrong with that. Jay's got a great point, so we'll see if we can talk more about that. He's
and
on
another one. Sorry about the background noise behind me. It's what happens when I'm in the newsroom. You know, they get a little crazy out there. Let's see. Jane sent this in. I'm back again after a couple of years and still enjoying the program. Had a couple of comments. I love your program because I was a child who desperately wanted to be a meteorologist, however, was talked out of it in mid-high school. I was told it would be impossible and often wonder what would have happened if I had defied the warning and still did. I'm even considering undertaking some study for fun outside of my day job. So, Jane, you can always go back and learn. There's no age limit on it. It doesn't matter if maybe you missed a younger opportunity to get into it, but if you still have that interest, I encourage you to study what you want, study what you can.
Well,
no, it's never too old.
Doing on your own time is you don't have to do all the math. You can just do the fun parts.
There you go. That's very true. Also, the widespread drought in Australia could briefly be covered on our program and how the weather there and here relates. For example, where I live in Brisbane, Queensland, we had major floods in 1974 and 2011, 2 years of major tornado outbreaks over there. Well, isn't that interesting? We have an expert on teleconnections.
Ethan, you're a teleconnections guy, aren't you?
Don't look at me. Yeah.
Speaking of,
get Gary on the show.
No. I do hydrology. I don't do teleconnections.
Exactly.
No, we got to get somebody from Australia on the show.
No, we do. We've never had an Australian person. I'll work on that.
No. Yep.
Get my note cards over here. Australian person.
Australian meteorologist. Yeah.
Oh, not just a person. You want a meteorologist.
I want somebody that does weather for the government or private sector. Somebody from down under to come on the show.
Oh, so not
Number
just
one,
any Australian. Okay.
So it just can't be somebody that works at Outback, huh?
No, that doesn't work. No, it would be interesting. Number one, to hear their perspective and on the science, but I like to hear them talk. I mean,
yeah, there you go. That's the real
I
reason.
feel like I'm listening to Crocodile Dundee. It's awesome. Just awesome.
Love it. Love it. All right. So that's a nice little sample from our email inbox. If you have an email that you would like to send us, email at weatherbrains.com. You can send us a guest suggestion with some contact information. Bill would appreciate that. A show suggestion, what you like about the show, what you don't like, if you have a cool topic, or if you see a cool article or something interesting that you think we should know and that we may have missed. Because we're good, but sometimes we're not that good. We miss things. So go ahead and send those over to us. Email at weatherbrains.com.
Hey, James, she's really good at this email thing.
She really. She should be
horrible
the permanent email officer. All right, let's do a weather roundup.
When the weather ball is red, warmer weather is ahead. When the weather ball is white, colder weather is in sight. When the weather ball is green, no change in the weather is foreseen. When colors blink by night or day, precipitation's on the way.
This is a weather roundup for October 1st, 2018, and we are getting into a high amplitude pattern. How about an eastern ridge and a western trough, which means, Ethan, come late this weekend over the weekend, you might see some snowflakes out there, huh?
That's what we're hoping for, at least in the mountains.
Yeah, and in fact, some of the guidance is suggesting blizzard conditions for parts of Wyoming and Montana, maybe Colorado, in about 5 or 6 days from now. That'll be interesting to watch. And so while we have that happening in the west, Aubrey, you are under the ridge. Are people getting cranky because it's too warm?
Well, I just got back from vacation, so I have not run into many people yet. And I will tell you that I experienced a temperature of 39 degrees on the top of Mount Greylock in the Berkshires. I nixed the hike.
Wonderful.
I got to the top and I said, nope, not going to do it. But yeah, I think a lot of people are tired of the humidity because of all this moisture we've had. It's been a terribly humid summer. We're in the Blue Ridge Mountains. We typically don't get the humidity. So we are all cranky and ready for some fall conditions. And I will tell you right now, our foliage is about 2 weeks behind. 2 weeks.
Wow. So down here, we had, looking at numbers for Birmingham, this was the third warmest September on record. Not close to that nasty summer of 1925. Bill Murray, were you forecasting the weather back that month? No, it was Brian Peters. That's right, that was doing that. September of 1925, we hit 112 on the 5th of September that month. It was brutal. But the ridge has been almost a permanent feature here since September. And looks like it's going to stay for about the first half of October. And then there's evidence of a good pattern flip beyond that. But this high amplitude stuff is pretty interesting. Tropics, we have Leslie in the middle of nowhere, stays in the middle of nowhere. We like that. And then we have the remnants of Rosa coming up into the southwest United States. Flash flood watches for parts of Arizona, Nevada. And
not quite to Ethan, but 1 to 2 inches of rain in southwest Colorado around Telluride, up to 4 inches in localized areas. That'll cause some mudslide problems.
Yeah, and they had such a dry year last year. They could use any water they can get, but what they need is snow, not rain. Yeah, I was trapped in Telluride once with a mudslide.
Yeah, that Box Canyon. You had to climb out the back way there. Go to Uri.
These Eastern Pacific hurricanes can really drop a lot of water when they come in. I'll never forget. I was in Tulsa, of all things, at a hydrology conference, an AMS severe weather hydrology conference. There was an Eastern Pacific hurricane by the name of Tico that came up, and we had a massive flash flood during the hydrology conference. That was kind of awesome. So that'll be a big deal for the South. Yeah, apparently they got a free show. You go to hydrology conference, you want a flash flood. So we had a flash flood. All right, so that's what's happening around the nation. It is time now for Pics of the Week. This is where we go around the horn, and everybody, Ethan, we're going to stall, and we'll pick you last. Everybody's going to share something weather-related. It's going to be a website, hardware, software, app, book, anything. Instruments. So that's the deal. So let's see if Aubrey has a pick of the week for us this week.
I'm about a week late on it, but it is an article on the 80th anniversary of the Great New England Hurricane of 1938. I did a lighthouse cruise that took us down to the shore across Long Island Sound, the shore of Connecticut and Connecticut and Rhode Island, and got to see Napatree Point, which was completely leveled and decimated during the 38 hurricane. A couple dozen houses on that little kind of a barrier island, and basically just rocks that were left. So very interesting to see, of course, the book The Sudden Sea about the 1938 hurricane, but also a great write-up from NWS New York about the hurricane, and something a lot of people still actually talk about in New England.
Awesome. Good deal. And the links will be up on the website, weatherbrains.com, for those of you that are listening. Our producer, JP, is filling in for Brian, doing the show notes. My pick, it is from NASA's spaceweather.com, the chill of solar minimum. The sun is entering one of the deepest solar minima of the space age. Sunspots absent for most of 2018. The sun's ultraviolet output is sharply dropped. New research shows that the Earth's upper atmosphere is responding. What does it mean? Interesting piece to read there. So again, that'll be up on weatherbrains.com. All right, Ethan, we're now throwing it over to you for your pick of the week, sir.
All right, so I was going to try to tell you about the NASA's Airborne Snow Observatory, because it's this amazing thing, but you're going to have to look this up another time. Apparently their website's down. So I'm going to talk about Japan's Hayabusa, I'm sure I butchered that, 2 mission. So I don't know if you saw this. This is in the news this week, where Japan basically landed a couple of tiny little landers on an asteroid, and they just sort of bounced along the surface for a little while taking pictures. I have to admit, I don't know what's happened to them in the last few days, but it's just amazing to think that we can send something off into space and intersect a relatively tiny rock just floating out there and land something on it. So I thought that was pretty cool to see.
Awesome. So you can give us a link maybe in the chat room or drop a note to Bill. That's awesome. All right, Bill Murray, what you got? What's your pick of the week?
Yeah, well, after all that, James, I'll take the foghorn.
What?
Really?
I just want to hear the foghorn. Yeah, but I'm gonna redeem myself with a great guest lineup that's coming up. But I had to tell Aubrey, Dr. Lourdes Aviles from Plymouth State has added a chapter to her book, Taken by Storm.
Oh.
And if you go back and look at some of the AMS conversations, I think they had an Ask Me Anything session with her last week. And there were some really good things about it, because that storm was becoming extratropical as it made landfall. And she has some great, fascinating information in there. But next week, Brian Elbing will be with us. We'll be talking about the acoustical signatures of tornadoes. Rusty Smith from Auburn University will be from the Rural Studio will be talking about some affordable housing and the considerations relating to severe weather. Rich Thompson, our old friend from the SPC, will finally join us on November 5th. Tony Rice is in charge of the show on the 12th. Matthew Porcher will be joining us. That's going to be a lot of fun. Author Gary Allen Fine wrote just a signature book about weather forecasting in the National Weather Service about 8 or 9 years ago. One Kim Cloco McLean had told me about. He's going to join us on the 19th. Dr. Ken Dewey, University of Nebraska, is going to join us on the 26th. And then, as we had the breaking news a little earlier on Monday, December 3rd, Curtis Alexander from the HRRR development team will be on with some of his crews. That's just some of the great guests that are coming up and here in future weeks on WeatherBrains. James, thank you tonight, Ethan. Great show. Really enjoyed all the great talk about that. And thanks to Scott Martin for helping me kind of prepare for it.
Thanks for having me on.
Hey, Ethan, what's going on out there at NCAR? What's the big story out there? What's happening?
What's the big story? I don't know. There's always something new happening, and it's hard for me to keep up with all of it. We're in, I don't want to say turmoil right now, but we're going through a nationwide search right now for a new director, actually. So that's going to be a big news item coming up. But at the moment, we don't have anything to share there.
Are you on the short list, Aubrey?
I'm about to say it's either Aubrey or Ethan, one of the two. Which one's going to be here?
Put in a good word for you.
Appreciate that.
But one question, Ethan, and we got to wrap this up in a second. There seems for years people have always been griping about this big gap between researchers, what you do, and practitioners, which is what we do. Do you think that gap has narrowed in recent years?
I do, but I have to admit I probably have a warped perspective on it. So as you introduced me in the beginning, I'm at the Research Applications Lab, and so our whole mission is really to do just that, to take research and get it into applications. So a lot of the work I do is with the end users, really, and working with the Bureau of Reclamation and the Army Corps of Engineers to help them understand the latest research in climate change and hydrology and how that's going to affect them, so they can try to take the latest information and get it in there. But then just on the Weather Service side, I think we're about to see a big leap as they have actually been upgrading their supercomputers and being able to move on. So fairly soon we'll be moving on to these newer generation of global weather models. I think that may make a big shift. And on the hydrology side, there's now the National Water Model built at NCAR, actually, the Wharf Hydro base. The National Water Model running at the National Weather Service 4 times a day and on a super high resolution grid. So they're predicting hydrology forecasts every 250 meters across the whole U.S. There's pros and cons, but it's pretty cool to see it stood up and running.
Hey, have you had a chance to visit the National Water Center in Tuscaloosa, Alabama?
I haven't, and I'm feeling a little left out because almost all of my colleagues here at NCAR have. But it's on my list. I'm sure I'll be there at some point soon.
Yeah, come see us. We'll show you some college football too.
Yeah.
We'll get you some college football, some ribs. No, I saw that model in action. That water model. That thing is stunning. The grid resolution. You can go down and look at Bill Murray's backyard on this thing. That little creek behind his backyard. It's just stunning.
That's right. Straight downhill.
I would love to know what kind of computer platform this thing is running on. Think of the computer power you have to run that thing. That's stunning.
It's 1,000 Commodore 64s.
Only 1,000.
and a couple of VIC 20s thrown in. All right. So Ethan, if somebody, are you on Twitter, Facebook? If somebody wants to get in touch with you, what's the best way to do that?
Probably just emailing me at my NCAR email address. So it's Gutmann, Gutmann at ucar.edu. UCAR, UCAR.
Awesome. Well, thank you so much for being on the show this week. We've had a great time, and we have got to wrap this thing up, and it's got to step across the hall and do some television. For those that are listening, we thank you. Most people listen, we know that, but some of you watch. We have a video version, and you can watch us live. We typically produce the show Monday evenings at 9:30 Eastern at live.bigbrainsmedia.com. That's what most people watch. But we know, again, that a lot of you listen to the show. If you want to get in touch with us, the email address, it is email@weatherbrains.com. Our social media accounts, the show notes are all on the website, weatherbrains.com as well. So thank you for listening. On behalf of the entire WeatherBrains crew, I'm James Spann. Have a wonderful week, and God bless.
So, James, when are you going to get Taylor Hicks to cut us a jingle for the show?
Yeah, he does the Find Bomb stuff. No, I think I can make that happen. I know him, and I know a producer, and I know an engineer, so we'll make that happen. Hey, Ethan, thank you. Thanks for staying up late with us. We appreciate it.
Yeah, it was awesome.
Not as late for me as this for y'all. Yeah.
Okay. Thanks a lot. Y'all have a great
See
week.
ya.